Hey guys, today is the first day of us dealing with our parallel and perpendicular lines. We're dealing with these mainly because when we've dealt with our shapes so far with parallelograms, rhombus, rectangle, and square, we've talked about how they have to be parallel, the different sides have to be parallel, they have to have 90-degree angles in the corners. And this is kind of what we're going to do is take those shapes and put them onto a graph and then see, hey, is this actually a rectangle, is this actually a parallelogram, using the different slopes of those lines, okay? So as we look at this, we kind of need to go back a little bit to Algebra 1 and revisit some of the things that we've already seen from there. When we were dealing with Algebra 1, we dealt a lot with lines, our linear lines here, with y equals mx plus b. That hopefully rings a bell, at least y equals mx plus b. If it doesn't, quick reminders, our m represents our slope, our b is our y-intercept. Those are the two kind of key things as we deal with our graphs and as we deal with our parallel and perpendicular. Okay, our slope, quick reminder we talked about in class today, our slope, a lot of people have heard it as rise over run. What I also like to talk about is up and down over left and right. Okay, it seems kind of silly, it might seem kind of simple, but I usually treat it as up and down over left and right. That way I can also put the positive and negatives where they go. So it tells me if I'm going up, it's got to be positive on the top, down is negative on the bottom, to the right is positive on the bottom, to the left is negative on the bottom. That's just kind of my way of getting past being unsure about rise and run. Okay, so you can think about it as rise over run or up and down over left and right. When we get into each of these, parallel and perpendicular, I had some students go through a decimals activity that talked about or kind of showed you the different pieces of why things are parallel versus perpendicular. When we looked at them, we noticed something about all of our parallel lines was our slopes were always the same. So that would be something that's kind of key. With a parallel line, our slope will always be the same. The y-intercept doesn't necessarily have to be the same or even close, but the slope is the same. What that tells us is its rise over run is going to be identical, so they're going to continue going in the same direction but never touch each other. Similar to like railroad tracks or any other thing that kind of continues on forever but doesn't touch. Okay? So for this equation, we talked about our graphing. It's the one kind of spot in math that we really like to have fractions. We like these to be fractions, so I can put this as 2 over 1. My first point is always going to be my y-intercept, so I'd go up to 4, 1, 2, 3, 4, put a dot here. Our slope is 2 over 1. It's a positive 2, so it tells me to go up 2. Positive 1 tells me to go right 1. So I'm going to go up 2 to the right 1 and put a dot. Normally I'd continue on as far as I can go. For this one I kind of run out of space. So if I run out of space, I'm going to go the opposite direction. So I'm going to go, instead of up 2 to the right 1, I'm going to go down 2 to the left 1, down 2 to the left 1, down 2 to the left 1, as far as I can go until I run out of space. Obviously my graph's not perfect. That's why you're going to see a little bit of a squiggle here. But it should be a straight line. If your line does not look somewhat straight, then you know something went wrong because it's supposed to be linear, it's supposed to be a straight line. Our second one here is another positive 2 and positive 1, so it's up and to the right. I'm going to start at my y-intercept of negative 1. Again, the key thing is make sure you are starting at your y-intercept and then doing your slope. So I started at negative 1 on the y-axis. Positive 2 tells me to go up 2 to the right 1, up 2 to the right 1, up 2 to the right 1, forever and ever. Opposite direction would get me somewhere in here. So again, mine are a little funky because I got a little further away on my actual graph. But you should see two lines that look like they're never going to touch. Okay? That would be our representation graphically, that these are parallel. And looking at our equation, you should be able to tell if their slopes are identical, then we know this thing's going to be parallel. Perpendicular is essentially we're dealing with the exact opposite. Okay? So perpendicular is the fancy version is called opposite reciprocal. Or what I told some of my students that they can kind of write or think, and I'm going to kind of draw an arrow for space-wise, is you flip your fraction and sign. Okay? Opposite reciprocal, opposite means is dealing with our sign, we're flipping our sign or making it the opposite. Reciprocal is talking about our fraction, it's flipping that fraction over. The exact same numbers, just flipped over. Okay. So when I get into my problem here, I know this isn't a perpendicular graph or perpendicular lines because I have 1 over 3 would be our first one. It's positive. My second one is now negative, so the sign flipped. And this is the same thing as 3 over 1, so I can see my fraction flipped and my signs changed, so I know this one's going to be perpendicular. Okay. When I go to graph this, again, this is kind of the one instance with parallel and perpendicular that I can kind of trust my eyes a little bit when I go to graph it, is it should look like it's going to hit at 90-degree angle. That's what perpendicular means. So for this, as I graph it, I have up 1 to the right 3 starting at -2. Again, this is my y-intercept, so I'm at -2. Positive 1 tells me to go up. Positive 3 tells me to go to the right, so I go up 1 to the right 3. I don't have any further I can get, so I'm going to go down 1 to the left 3. Again, giving myself somewhat of a line. My graph hand-drawn is not super great. And then my second one here, again, I made it into a fraction by putting 1 underneath. My y-intercept is positive 2. My slope is -3, so it tells me to go down, and a positive 1 to go to the right. Something that I see every year with our students is when I see this negative, I often see students thinking both the top and bottom are negative. We will always treat it as if the top is getting the negative. Okay, so if you have a fraction where it looks like this and they have -2/3, we're going to treat it like it's -2 over positive 3. Okay, that just keeps it a lot more simple as far as what we're dealing with, and we'll never be able to have both of them negative in this instance. Okay. So here this tells me to go down 3 to the right 1 starting at 2. So I go down 3, 1, 2, 3 to the right 1. Down 1, 2, 3 to the right 1. Gives me my graph. Again, hand-drawn kind of mistakes you might see a little bit, but this graph should look something like a 90-degree angle where those two things hit or intersect. Okay? So again, this is as far as we got today talking about our parallel. Remind us that our parallel lines or equations should have the exact same slope, whereas perpendicular should have the opposite reciprocal slope or a flipped fraction and sign from the other equation. Okay? Hopefully this kind of helps you a little bit as far as our parallel and perpendicular, dealing with our slopes and how to identify those different lines. If you've got any questions, feel free to shoot me an email. Otherwise, I'll see you guys soon.